Dear friends, in our last lecture, we had seen that the data are collected and classified for further statistical analysis. We had also discussed the difference between the variable and attribute as well as continuous and discrete variables. If the variable is discrete and we have frequencies corresponding to each value, we obtain frequency array. If the variable is continuous, we obtain frequency distribution. Friends, today to continue our discussion on the theme of organization of data, we will discuss about how to construct frequency array and frequency distribution one by one. First of all, let us discuss the frequency array with an illustration. Let us take the first illustration. 20 students in a class decided to evaluate the performance of the teacher. Rating was done on a scale of 1 to 5, where rating 1 indicates the best performance and the rating 5 indicates poorest performance. The results are shown on the frequency array given in the table 1 on the screen. In this case, the variable x is rating. It is a discrete variable which takes values 1, 2, 3, 4 and 5. The number of students represents the frequencies. There are 4 students who gave the rating 1 to the teacher. There are 6 who gave the rating 2 and so on. The total frequency is 20. However, the counting of frequencies can be done more conveniently if we use tally marks or tally bars. Let us illustrate this with table 2, which is shown on the screen. We put a single tally mark for each student. There are 4 students who gave the rating 1. Therefore, 4 tally marks are placed against x is equal to 1. 6 tally marks are placed against x is equal to 2 and so on. For convenience, the 5th tally mark is shown across the earlier 4. This helps in counting. Let us now see the construction of frequency distribution. Look at the table where we are given the percentage of marks in mathematics obtained by 100 students in a certain examination. Let us now construct a frequency distribution for the data in table 4 shown on the screen. As we have noted before, there are several alternative ways of choosing the number of classes, their size and their class limits. Suppose we choose 10 classes such as 0 to 10, 10 to 20 up to 90 to 100. All class intervals have the same width 10 and the upper class limits are equal to the lower limits of the successive class intervals. Let us use the working rule that the upper limits of class intervals are excluded, but lower limits are included. Thus, if a student gets marks equal to the upper limits of some class interval, we classify him or her in the next class. Friends, look at the table 4 shown on the screen, where the frequency distribution is shown. As you may see that the counting of frequencies is done by placing tally marks against various class intervals. A tally is put against a class for each student whose marks lie in this class. For example, if the marks obtained by a student are 57, we put a tally against the class interval 50 to 60. If the marks are 71, a tally is put against 70 to 80 and so on. If someone got 40 marks, the tally is put against 40 to 50 as per rule. It helps in counting the tally marks if 4 of them are put as the bars slanting to the right and the fifth is shown by placing a bar slanting to the left, cutting across the earlier 4 bars. Thus, we can say that the frequency in any class is equal to the number of tally marks against this class. Let us take another illustration to construct the frequency distribution. Look at the table 6 shown on the screen. Here, the data on daily wage earnings in rupees of 40 individuals are given. We may treat the variable daily wage earning as continuous. Observe that the maximum wage rate is rupees 800 and minimum is rupees 85. Thus, the range is R is equal to 715. Let us choose the width of class intervals as H is equal to 100 and specify the classes as 70.5 to 170.5, 170.5 to 270.5 up to 770.5 to 870.5. Now, you can see that how the frequency distribution is shown in table 6 on the screen. Once the data have been grouped into class intervals, we obtain the frequency distribution. The frequency distribution gives the number of observations, that is frequencies, in different classes, but not their actual values. All values in any class are assumed to be equal to the middle value of the class interval. This leads to the error of grouping. For example, look at table 6 once again. In this table, there are 12 values in the class 70.5 to 170.5 which are shown in table 7 on the screen. We assume them all to be equal to the middle value half of 70 plus 5 plus 170.5 is equal to 120.5 of the class interval. Thus, the error of grouping in each case is shown in table 7 on the screen. Now, look at the table 9 shown on the screen. Here, the actual values, that is wage earnings, in different classes are given. Thus, we should note that the total error of grouping in any class will be small if the values are uniformly distributed within the class and the class interval is not too large. In that case, the positive and negative errors will tend to cancel out. Now, we will discuss about the bivariate frequency distribution. Very often, when we take a sample from a population, we collect more than one type of information from each element of the sample. For example, suppose we have taken a sample of 20 companies from a list of companies based in a city. Suppose that we collect information on sales and expenditure on advertisements from each company. In this case, we have bivariate sample data. Such bivariate data can be summarized using a bivariate frequency distribution. A bivariate frequency distribution can be defined as the frequency distribution of two variables. Look at table 10 shown on the screen. It shows the frequency distribution of two variables, sales and advertisement expenditure in rupees lakhs of 20 companies. The values of sales are classed in different columns and the values of advertisement expenditures are classed in different rows. Each cell shows the frequency of the corresponding row and column values. For example, there are 3 firms whose sales are between rupees 135 and rupees 145 lakh and their advertisement expenditure are between rupees 64 and rupees 66,000. The use of a bivariate distribution would be taken up in the chapter on correlation. Thus friends, we have discussed today that the data collected from primary and secondary sources are raw or unclassified. Once the data are collected, the next step is to classify them for further statistical analysis. Classification brings order to the data. Once you know the technique of classification, it will be easy for you to construct a frequency distribution both for continuous and discrete variables. We have now understood that if the variable is discrete and we have frequencies corresponding to each value, we obtain frequency array. Frequency distribution shows the classification of the data for a continuous variable. Hope you have understood different ways of organizing the data.